So this is the, sorry, I don't know. So this is the video for the formula part of our concentration classes. I will be doing another video where I go through some example problems, but this is just, I'm gonna just note down the formulas and explain them, and that's about it. So the first worksheet that we were given, that I gave you, I'm rethink. So we're not gonna do like any of these things because you don't really need to know how to draw tables and stuff. That's kind of pointless if I really think about it. It was helpful to note down the stuff that we were doing in our lab, like, well, I won't really call it a lab, when we were mixing solutions, how to calculate it, but in essence, you won't be given any questions that need you to draw the table, so we're going to ignore the table. We will, although, define what a solute, a solvent, and a solution is. A solute is something that is dissolved. And this is usually like your salt or your sugar or your hot chocolate powder, right? So this is a solid. Usually it can sometimes be a gas or a liquid, but it's the substance that is dissolved. It's usually present in a smaller amount than your solvent, which is the something or the medium or substance. I should really say substance instead of something. Let me just erase that and say substance because that sounds better. Again here, I'm going to say substance that the solute is dissolved in. So this is usually your water or milk or any of those things that you put salt, sugar, or hot chocolate powder into. So solute is the substance that is dissolved, and solvent is the substance that is doing the dissolving of the solute. And your solution is basically what you get when you have a solute plus a solvent. So when you put those two together, you essentially have a solution. When you have a solvent like water and you add sugar, you get a solution of sugar water. If you have a solvent of milk and you add hot chocolate powder, you get a solution of hot chocolate drink. And that's basically all we are going to talk about on this worksheet. But this worksheet is very important because we have a summary of our formulas, and this is what we are going to be using for almost all of our calculations coming up. Okay, so molar mass. So we need to know how to calculate molar mass, and you add up all the atomic masses of the elements, right? And that's how we know to calculate our molar mass. We need to know how to do that. You look at a periodic table, you look up all the masses of all the elements, you add them all up, and you get your molar mass. For example, if you have NH4OH, you're going to look at the periodic table, you're going to take atomic mass of nitrogen, 4 times atomic mass of hydrogen, atomic mass of oxygen, and 1 more atomic mass of hydrogen. You're going to add them all up, and you get your molar mass of this compound, right? Super important to know how to do that. But the formulas that we're going to relate to molar mass is these formulas, essentially. Whoops. Oh, yeah, okay. I'm doing this right. Number of moles equals mass. And here, N is the number of moles. Small m is our mass in grams. And big M is our molar mass, units of gram per mole, right? And here we can see that if you want to find number of moles, you have to take the mass divided by molar mass. If you want to find the mass, you take number of moles and multiply it by molar mass. So that's why we need molar mass to go from mass to moles or from moles to mass. Yeah, I said that the other, but you get the idea. So these formulas we've done before, but they're very important to remember because we're going to be using that a lot. Okay, next is mass percentage. W per W. This W stands for weight. So W over W means you're taking a ratio, or you're doing mass over mass. So this is the mass of solute divided by mass of solution times 100%. So we talked about what a solute in solution was. If 5 grams of sugar are dissolved in, we'll do an example, 5 grams of sugar in 80 grams or milliliters of water, right? Because we know for water the grams equals the milliliter, so it's pretty easy to do that. We are going to take mass of solute as 5, mass of solution is 85, or 80 plus 5, which is 85 times 100%, right? So this is 5 over 85 times 100%. Very important that we have to do this addition because we're taking mass of solution, which is both the solute plus the solvent, right? The only difference by when I mean W per V is I'm doing weight per volume. So this is mass of solute. This is the same because it's a weight divided by, instead of mass, I'm doing volume of solution times 100%. And this is a bit easier to do because if I do the same example, 5 grams of sugar and 80 milliliters of water, I will do 5 divided by 80 times 100%, because my volume of solution, my sugar does not contribute to my volume. My sugar isn't increasing my volume, it's just increasing my mass. Because if I take 80 milliliters of water, I dissolve sugar in it, I'm still at 80 milliliters of water. I haven't increased the volume. So the volume of solution is basically the volume of the solvent. Unless, of course, your solute is liquid, which we will never see. So, for the purposes of this course, we will never see. It is possible, however. We will just quickly skip molarity for now, go to ppm and ppb, because they're very similar formulas to what we just seen. Parts per million, and this is mass solute divided by mass of solution. Instead of times 100%, we're going to times that to 10 to the power of 6 ppm, and 10 to the power of 6 is 1 followed by 6 zeros, right? And that's what a million is, and that's why we get the name parts per million. It's important to note that even though we have a mass of solution here, very similar to our weight per weight, this we can approximate to be mass of solvent instead. Because, why can I do that? Because let's say I have, again, 5 grams of water, but if I'm doing a ppm, 5 grams of water, if it's 5 ppm, 5 grams of water is dissolved in 1 million grams of or solution, right? So essentially, whether I do 5 divided by 1 million solution, or 5 divided by, if million was the solution, 99995 was the water. This was the solvent. Whichever one I do, I will get approximately the same answer. This is not going to make a big difference to my calculation. I'll even show you. This would be 5 divided by 1 million is 0.000005. And if I do 5 divided by 1 million minus 5, I get 0.000005, which is the same thing, but after that I have 0.00025. So it's, I didn't write that clearly enough. Okay, moral of the story is, I'm not even going to write that. Moral of the story is it's a super, super small difference between this and this. So essentially I can say massive solvent instead of massive solution and I will get the same answer. It's always easier to do massive solution, so we're going to stick with that. Depending on which way, it might be easier to do one or the other, actually. So whichever way is easier, use that. Here we have parts per billion, and this is the exact same thing. Mass of solute divided by mass of solution or solvent multiplied by 10 to the power of 9 ppb. So 10 to the power of 9 is a billion, 1 followed by 9 zeros, and that's parts per billion. Again, used for very, very small concentrations. We will jump back here quickly to molarity, which is one of the only formulas that uses number of moles. So molarity, also known as molar concentration, or C, equals number of moles divided by volume in liters. So very important that the units are in liters. So we even see here that all the units we've done so far are gram and milliliters. That's the only units we're using. This is the only formula that uses volume in liters, so it's very important to convert any milliliters to liters by dividing by 1,000. So here, molarity is given, or molar concentration is given by the letter capital C. Number of moles we know is little n. Volume we can write as capital V. So we get the formula C equals number of moles divided by volume. And this is the molar concentration. The units of C are in moles per liter, or molarity, capital M. And I know that's confusing because capital M also means molar mass. This capital M is a unit and not a letter that represents molar mass. So if you don't want to use capital M, and I will put mole per liter in all my questions on the test. I'm afraid some of the questions here do have the capital M, so I'll address that when I get to those questions. Right, so we have the formula C equals number of moles divided by volume, and the units of C are moles per liter. The last thing we will do is if we're diluting a solution. So what does dilution mean? Let's say I have a beaker. I have a known concentration, so 0.1 moles per liter of like some acid like hydrochloric acid, and I have like 10 milliliters of that. And let's say I want more of this solution, and I'm diluting it by adding more water. So let's say I add another 90 milliliters of water. This is what is called dilution, because I'm diluting the acid with more solvent, right? It's like I have a hot chocolate and I'm diluting it by adding more milk. So the hot chocolate is getting more dilute. I'm keeping the same number of hot chocolate powder. I'm not changing that. I'm the same number of HCl. I'm just adding more water, or in the hot chocolate case, milk, to my solution. So what this says is that before dilution, if I multiply the concentration and the volume, here this is 0.1 times 10 milliliters. Remember, I have to convert to liters, so 0.01 liters. This is my C concentration times volume before dilution, right? And this is going to be the same as, I don't know why I put the arrow there, equal to C2V2, which is my concentration times volume after dilution. So after I added my 90 mils of water, my total volume becomes 0.1 liters, because that's 100 milliliters total, right? Very important here. My total volume is 90 plus 10 is 100 milliliters, which is 0.1 liters. I have to add, because I already had 10 and I added 90 more, so my total volume became 100. And this concentration now will become 0.01 moles per liter, right? And this is because I have diluted, so my concentration is going down. And that makes sense because if I take hot chocolate, I make it too concentrated. I add more milk, I'm making it more dilute, right? So my concentration does decrease. So as my volume increased, my concentration decreased. And that is basically the law of dilution. We'll do practice problems in the next video for both these cases using these formulas. I will see you guys and girls in class.